Welcome back. So, trigonometric reciprocal functions. If you have gone through high school math and probably starting in grade 10 and then going into grade 11, and now if you're, say, in grade 12 and you're maybe taking advanced functions, you're going to be running into trigonometry quite a bit. So in this video, I just want to briefly talk about reciprocal functions for these trigonometric functions. So you should be very comfortable, okay, when you're walking into grade 12, or at least if you're not, you can, certainly get yourself up to par on the functions of sine of x, cos of x, and tan of x. So trying to graph these, I kind of utilize the unit circle, thinking back of that. So, if I kind of scroll down here as I prepared this, this was the unit circle that I created, and we have our x and our y's, and we can get our sine, and then we can get our cos, so which really are just the ratios of the triangles that we're creating, right, as the unit circle is kind of being built up. So from these, for instance, so here is the sine of x, okay, so that I kind of plotted on decimals and I, clocked it into here. And when you are going to be doing reciprocal functions of any kind, so I did a video on reciprocal functions for, very kind of polynomials. And then if you take the reciprocals, you're going to get a rational function. And it was very useful to use the original function and then to be able to graph the reciprocal. So if you've forgotten about those reciprocal functions, I'll put up a link up above there for you to get yourself back in. Now, if you don't remember, the unit circle, put up another link, okay? So I'll put that one up above there so you can kind of refresh yourselves on those items. Because when you're doing reciprocals, I mean, what do they mean? Well, so you can take any function, so let's say sine of x. And if I take the reciprocal, then all I'm doing is I am just swapping it over, okay, and I'm putting it over 1, and that would be the reciprocal function. Now, what did we call this? So the reciprocals of sine, so basically this was, okay, the cosecant one that we would have. And if you would take the reciprocal of your cos, okay, which would be just 1 over, and this would be cos of x, and then now what did we call that? Well, this was just the secant, right? And then if you do this right here, so 1 over tangent, then this would be just cotangent. So this was COT. And that's what these functions really are. So if we wanted to plot one of these. So let's say if I wanted to take, I'm going to just take this one, for instance, and I wanted to be able to plot it. So if you know what a sine looks like, so here's your sine, and I put it in degrees. Now you can very easily put it in radians. So instead of, 360 as being the period of our function, it could be 2 pi, right? So that just depends. You can set those settings in decimals as well to try to plot it. Now, what do we know about the reciprocals? Well, first of all, for these trigonometric functions, we know that they have a period, right? And then they just repeat. So for instance, for us, so if I would kind of graph this out, I know that there is a period within here that this sine function, so if I take this from 0, right, to basically 360, so if I'm going along here, and this is my 360 right there, so that's one period of it, right? 360 degrees, and then it just keeps repeating, right? And I can do that to the left as well. So here, if I go into negative 360, here's another period, and then again, it just keeps repeating. If you want to graph the, let's say, cosecant, okay, of your sine function, then what do we know? Well, the reciprocals, we know that at zeros, because if we would take the reciprocal, right, and we take a look at this, so wherever sine of x is 0, which we know, so if you take this, so it's going to be, right here, okay, it's 0, right here it's 0, and then it comes back again, and here again, so at all of these different points, we know that sine of x is 0. And if we take 1 over 0, so that means at these particular points, right, our cosecant, so our actual reciprocal doesn't really exist. It's undefined, so it just skyrockets through. And I like to, when I graph this, so if I would know that, I'm going to remove these, okay, and then I'll put kind of a dotted line, or maybe, maybe I'll keep it, but I'll just do it in a different color. So at all of these spots, wherever it is 0, we know that our reciprocal is undefined, right there. So it's going to be blowing up on us, okay, as we come close to these points. So I'm going to be graphing this like that. So this is just for the sine, okay, and then the reciprocal of my sine. So that's my first step if I wanted to graph it. So there we have it. All right, so that's that. Now, the next item is, okay, if we're going to be taking the reciprocals, and if you like, we know what these values actually are, right? Like if we think back of the unit circle, if I think back of this, well, if I want to graph my sine, well, then we know that it's the y value from the unit circle, right? So it starts from 0, goes to a half, then it goes to square root of 2 over 2, square root of 3 over 2, back to 1, and then it just kind of reverses through. So those points we can graph. And if you take the reciprocals, then they just flip, right? So it's literally a reciprocal, like you would do it for a fraction. So at 0, if you do the reciprocal, it's going to be 1 over 0, which is undefined, okay? And then at a half, if you flip that, then that's 2. Okay, and then so on and so on. So you can do those reciprocals to find your cosecants. That isn't anything new to you. You certainly have studied that cosecant, okay, and secant, and then cotangents, but you maybe haven't graphed it yet. So in this case, what I like to do is, so right here, if I'm actually trying to graph this out, I'll start here. Okay, because at 1, so at all the values of 1, so at all of these values, okay, and then all the values of -1, so all of these values, well, the reciprocal is identical, because if I take 1 over 1, it's still 1, right? And then all the other values that I have, so if I would take any values along in here, so what happens if you take the reciprocals of these, okay, so what's going to happen is that your cosecant, instead of going down, it's going to actually start looking like this. It's going to start blowing up towards where it's undefined. It's going to touch back at 1, and then it's going to start blowing up again, okay, in this direction. So it looks like this, okay, on this range between 0, in this case, because I'm just talking about degrees, between 0 and 180, or between 0 and pi. Right? So as you go along in this direction, this will start to blow up because you're taking a reciprocal of a smaller and smaller. And as you go along this direction, this also will blow up. Notice it's positive and it's getting smaller and smaller. So now what happens on the opposite end? Well, on the opposite end, notice that if you go in this direction, okay, so as you go along in here and you start taking the reciprocal, okay, well then this thing is going to start to blow up in this direction because it's now negative. So it's going to go like this. Okay, and now if you go in this direction, your reciprocal again is going to start blowing up like that. Now, so what I have done here is I've really just plotted one period. And if I plotted one period, you can plot the rest. They're identical, right? So in all of these, okay, so this is going to look like that, okay? And you can just keep going and start plotting this out. So this is going to look like this. Okay, and then this is going to start looking like that. And that would be the plot, okay, of your function, okay, which is the reciprocal. So this would be the plot of cosecant. So that's what we would have there. Now, can you do the same, with the other ones? So can I now take, for instance, my function of cos? Sure you can. Now, cos and sine really are just translations by 90 degrees, right? Or pi over 2. So, in this case, what would happen is this would just get shifted over. And it would look the same thing. So my secant is actually going to look kind of the same. So, and I do have, so if I plot in here, I'm going to put in the cos. All right, so let me put that in from decimals. All right, so here it is. So that's my cos. And again, okay, so what I would have is wherever I have my zeros, so So those are the crossings of 0, so that I would have. So I have one here, all right, so then I have another one here, okay, and then I have, another one here, okay, and then another one here, and so on, all right? So you can put all of these crossings, okay, of zeros, because the reciprocals, again, are going to be undefined at these points. So what you have is now, if you wanted to plot secant, okay, of this, then that's going to look kind of a little bit different, but all it is just a translation. So now it goes like that, okay, and now this actually carries on through here, and you can do the same thing all the way, okay, in all of these. So I actually, believe it or not, I never tried to memorize the reciprocal ones. The sine and cos were very simple to try to remember because you do them over and over, and then you do translations with them. You can do translations with these as well. So that wasn't hard. And then to remember the reciprocal ones, I kind of actually visually remembered them like this, so that I could just do it, then just plot one period, and then it just continuously repeats. Now, of course, you can find the domain and then ranges, right, for all of this. So it's not really that difficult. So notice that for our, let's say this is for my cos function. So, I mean, if there's no restrictions, we know that the domain is basically all of x here, and assuming x is in degrees or maybe in radians, right, one or the other. Now, are there any restrictions with regards to the domain of the secant, right? Yes, of course, as we just said. So the domain is going to be everything except, right, wherever we have those 0 crossings. So now, where do those 0 crossings come in? So if it's cos that you're thinking about, or if it's sine that you're thinking about, for sine, we know that the crossing happens at 0, right? We know that the crossing happens at 180, right? And then it just keeps repeating them to 360, and so on, or 2 pi. So basically, every pi, right? So 0 and then pi, 2 pi, and so on, our sine, so if I go back here, so our sine would have been 0. Okay? Now, for that, what that means is, for your cosecant, so for the reciprocal, those are the values that your domain is undefined for, because you would have 1 over 0 there. And that's why, so in here, so wherever you see, okay, those yellow lines, you would say that, well, for x, okay, so x cannot be equal to, so we just said, can't be 0. It cannot be 180 degrees, right? It cannot be 360 degrees, okay, and so on. Now, if you're doing it in radians, really what you're saying is to, if you want to kind of formally define it, it would be n pi, for n is equal to basically just a whole number. So 0, 1, 2, and so on. So for all of those values, it's undefined, but for everything else, it's fine. Now, what about the range? Right? Well, the range within our sine function, so if we look here, it's basically restricted between 1 and negative 1 in here. But if you're looking at the range of your cosecant, well, you're noticing that it is actually everything above 1, so notice it goes above 1, or anything above negative 1. So for our range in here for this cosecant, you have to be careful how you define that. Because that domain, that range, right, it does not exist in this world between 1, okay, 1. It is 1, but it's less than 1, okay, and in between here. So it doesn't actually exist. So x in between, y for our range. Have to be careful here. So our y for our range, okay, between these values, okay, does not actually exist. So it is all of y except that. Now, how can you write it? Well, you can say y is basically greater or equal to, okay, 1. So that, we can certainly do, or we can say, okay, so it's definitely that, and then y is also less than negative 1. And then you can use absolute values to define that if you wanted to as well. All right, so that would have been your range. And you can do the same thing and try to define your, Okay, so secant. So again, the range is actually going to be the same. The domain is going to be different because your zero values, so these points right here, okay, are different. So, if you think back of the unit circle, then it's actually, whereas cos is equal to 0, well, it's at 90 degrees or pi over 2, and then at 270 degrees or 3 pi over 2, right? Those are the 2 points that you see here, and then they just keep repeating. So it doesn't exist there. All right, and the last one, I guess, which is, the tangent. So we can certainly try to graph the tangent because we know what it is, right? So if we have 10, okay, of theta or of x, I'll keep this one at theta, okay, is equal to sine of theta all over cos of theta. So that's just by definition on the ratios, right? So that's what we have there. And if you go back to the unit circle, and you start kind of plotting, if you wanted to actually plot 10, because I find sine and cos are easy to remember, but tangent in terms of the graphing it is not as easy. All right, so, you can go back to the unit circle and then just start from the beginning. Just do one full repetition and then you'll know, so one period all the way around, and then it just keeps repeating. And then so all you're doing is, if sine is basically the y value, and then x is the cos is the x value, and then you'll just put, so it's y over x, okay, and then you can just get it from the actual values and then start plotting them up. So here is a plotted one, so it kind of goes like this, and then if you plot a few points, you'll notice that at pi over 2 or at 90 degrees it blows up on you because that particular point that you have, because it's sine over cos, so cos is basically 0 there, right? So that's what we see here. So we have a blow up right here, okay, at pi over 2, and then just continues on, and then you'll have the same one. So wherever cos, okay, is actually 0, you're going to have these blow ups happening like this. So I'm just plotting them up. Okay, and now, so that's my, my 10, so my tangent, notice, so it kind of looks kind of funny, okay, it's definitely periodic, it keeps repeating, but there's, the domain you have to be careful about. So now, what if you wanted to plot the opposite, or the reciprocal, okay, which would be the cotangent? Well, with the cotangent, then what we would have to be careful is wherever we have zeros, right? These would be now the new blow-ups. Okay, so it would be right here. We would have one right here. Okay, we would have one right here. So that's what we would have, okay, as we would be going through. So those are going to be the new ones. And now you can just pick one of them. So I'm going to pick, okay, so the one right in the middle, and I'm going to kind of just see what is going to be happening in here. So I know that in here, okay, so what we have is we're coming down in here, right? Now, this point where tangent was undefined, which is at pi over 2, it was 1 over 0. So if you take the reciprocal, it's 0 over 1. So what that's going to do now for us, and maybe I'll do it in green. So that means this is going to become my new 0. So wherever tangent was undefined, if you take the reciprocal, it's going to be your new zeros. So those are going to be my new zeros, right? So that's how it's going to look like. And now, as I go through, okay, so within here, so as I'm coming down along this path, right? So as I'm coming down along this path right here, we know that it's going to blow up, okay? So that's definitely true. And so as I come close, as you get close to 0, so these new blow-ups, okay, are going to be causing, so this thing is going to go like this. Now, wherever there is a 1, so I mark these ones, okay, right here. So we're going to be crossing through that 1. And then, okay, so notice as you cross through here, okay, so this is going to get really small. It's going to go and hit the 0 at the undefined point. And then again, okay, because now you're going to be going in this direction, right here. So this is going to be going through here. It's going to cross through the 1. And now notice that it's going to start, because you're getting closer and closer to 0 along here. So this is going to start to blow up on us. So this is going to look like that. Okay, so that's 1. And that means that now once you draw that 1, it just keeps repeating for the rest of them. So this one's going to look identical, right? So it's going to go like this. Okay, it's going to go through here, and then, eventually it's going to kind of go like that, although we don't have the space for it there. And then in this one, it's going to be the same thing. So this one, as we come along down here, okay, in this direction, so it's going to go like this. Okay, it's going to go through that 1, right? It's going to go through 0 right there, and then it's going to start blowing up, okay, in here. So it's going to go through that -1 and start blowing up. All right. So that would have been your cotangent, and that's how you can draw that reciprocal. So use those reciprocals to your advantage. Learn the sine and cos as best as you can, and then you can, flip them. And then whenever you're stuck, you can always go back to the unit circle and actually start plotting a few points to remind yourself. All right. But for sketching, we can certainly sketch them pretty easy and find the domain and ranges as needed. All right. Okay, so thank you for watching. So that's another video. This is definitely for advanced functions, for those students who would be interested in trying to understand these reciprocal functions of trigs, which is cosecant, secant, and cotangent. All right. Hope you found this video useful. Take care, everybody. Bye.